So first, in today's training, I will introduce our Delta robot system. So in the Delta robot system, I will start to introduce the keywords of robotics. What's the keywords usually we will see in the robotics? And then I will introduce the Delta robot solution, what solution we provide, and then the system overview of a Delta robot, and then robot arm itself, and the quick start when you get the robot, how you do the wiring and all the settings to start to use the robot. And in the end, I will have some appendix about robot information. So let's today's contents. Okay, let's continue. So first is the keyword of robotics. So the first page there are four important keywords of the robotics. So first is the payload. Payload means in the end effect of robots, how heavy of your gripper or object or workpiece will be. And then this is very important for robot because when you are choosing robot, then you need to choose the payload is higher than your workpieces. Then robot can handle the workpieces. So this is the first keyword. And second is the arm length and or reach. So of course, when you choose a robot, you need to know the workspace, like in your machine or your production line, how long the robot need to reach. So you need to choose the robot arm, which is longer or just similar to the distance you need in the machine or your production line. And then the next one is standard cycle time. So this is so important for robot because we use robot, usually we want the speed, the fast speed of robot. So this is also a spec of robot that we know how fast the robot is. So that's even standard in the ISO 9283 that defines when the robot move in this path from the start path, go vertical up 25 millimeters and move horizontal 300 millimeters, and then go down vertical by 25 millimeters again. So this is one cycle, and the payload usually will use 1 kilogram to test. So in this path, how long the robot, how fast the robot will move will become a standard cycle time. So with the standard cycle time, you will know the speed of the robot. And the last is degree of freedom. So when you choose a robot, you will want to know how flexible of a robot. So I will introduce later that the Delta provide two different robot has two different degrees of freedom. One is a Scala, one is vertical articulated. So of course, if the degree of the freedom DOF is higher, then the robot is more flexible, but usually will be slower. But if the degree of freedom is smaller, like only 3 or 4, usually is faster, but then it's not that flexible of a robot. Okay, and the next page is another important idea in the robot. One is accuracy, the other one is repeatability. So usually you will only see repeatability as a robot spec in the brochure or catalog, but there's also another importance, accuracy. So let's see right picture to see what's the difference between these two ideas. So in the first picture, you can see the middle is our target. We want to reach this center point, and all those blue dots are the robot reach the target. So you can see all these dots not in the target we want, and it's really randomly. So we will say this robot is not accurate, also not repeatable. And let's see the second picture. you can see there's already some blue dots is already on the target, but not all of them. Still some is outside of target. Then we will say this robot is accurate because it's already reached the target, exactly the middle, some points, but not all of them. So we will say it's not repeatable. And let's see next picture, third one. You can see all the dots are really only on the same points. They are not randomly on the target, but these points are still not on the target. So we will say this robot is not accurate because it cannot reach the target well, but all the dots can stay in the same point. So we say this is repeatable because robot can always go to the same point. So in the end, the last picture, you can see all the dots are on the target, and also they are every time can be in the target. So we will say this robot is accurate and also repeatable. So what's this idea will affect our application? Because for robot, usually we only teach a few points, then they will reach every time the same in the application. So repeatability is more important for robot for now, because robot need to go to the same position every time. You cannot every time go to a different position. Then the robot is totally not usable. But now accuracy is more important nowadays because now robot not only working by itself, sometimes it will co-work with like sensors or a vision system. So when the position is not predefined before, it's come from vision system or sensors, then accuracy will be important because it needs to also be accuracy to reach the target, not just always go to the same point. So this is the accuracy and the repeatability. And next one is a robot type. So basically, there are many different industrial robot type in the market. And for Delta, we only provide 2 type of robot for now. So I only introduce these 2 type. So first is a Scala robot. It only has 4 degree of freedom because it only has 4 motors in the robot arm itself. And Scala stands for Selective Compliance Articulated Robot Arm. Why we call it Selective Compliance? Because in the 4 degree of freedom, the end effect here only can have compliance in the XY plane. So that's why we say it's selective, because we only stack XY plane to have compliance. Not all direction, like in the Z or XY or Z, they don't have compliance. So it usually has a parallel axis joint layout, like a picture you see. All the axis is in a parallel, and generally it will be faster because of its design. And the second one is vertical articulated robot. It has a 6 degree of freedom because it has 6 motors in the robot arm. And as you can see, it's more like a human's arm. So it has a more flexible than the Scala robot. It can go into a small space or go to a position with a different angle. Yeah, but generally it has a lower repeatability and also lower speed. Okay, and next I will start to introduce the Delta robot solution, what we provide of a robot station. So in the EMEA, in the Europe area, we start to provide our robots in 2018 with a Scala robot. And in 2019, we also released our articulated robot. And in 2020, this year, we start to release more different models, like maybe 5-axis skull robot. We attach one more axis here. It's become more flexible. And also some application robots, like a vertical articulated robot with some special application. And then here is our model name, because you need to choose the robots with the different specs. Then the model name will be important. So I will introduce the model name here. So first is the Scala series. So in the Scala series, it will start with DRS. That stands for Delta Robot Scala. And then the next is number 40. That means arm length. So you need to choose arm length with this number. So for now we have 40 means 400 millimeter, 60 means 600 millimeter. But in this year we start to have also 50 and 70 means 500 and 700 millimeter arm length. And the next is light series. Light series means now our controllers are outside of the robot arm is another cabinet, and the robot arm itself is quite light. So we call it a light series. So this L means a light series. And then next is also an important one. This number means the payload. So you need to choose payload with this number. And now we have 3 kilogram and the 6 kilogram version. And the next two will be about joint 3 and joint 4. So first, it's a Z-axis stroke. So for the Z-axis stroke, we have a standard length. But in some application, maybe you have or need a longer Z stroke. So you can have other options to have a longer Z stroke. And next is R-axis gearbox ratio. We also have a standard and optional gearbox ratio, because in some application, if you need higher torque of the joint 4, then you can select the higher torque or higher gear ratio version of R-axis. And next is the hardware version. So for Europe area, because we all need CE certification. So in this area, we only have one choice. It's A. A means IP20 and with C certification hardware. And next is the control type. And for control type here, we use for choosing the cable length. So for the cable between the robot and the controller, we have a 3 meter and a 5 meter option you can choose. And next is the TP. So this one will be a teach pendant number, but because in here our strategy, we sell teach pendant as other products, but you still can choose with a different cable length of teach pendant. So we have a 3 meter, 5 meter, and the 10 meter option of a teach pendant cable length. And the last is others is in the future, if we have other accessories, then we will put into this number to let you choose. Okay, so let's start. And the next will be a VA, vertical articulated series. So the same, the star will be a DRV, that means Delta Robot VA. And then next, the same will be arm length. So for now, we have 70 and 90 means 700 and 900 millimeter. And the next is also a series. Now we also only have light series, but in the future, we will release more different series, like integrate with drive into arm. Okay. And next is payload. Now it's we only have 7 kilogram option. And the next also the hardware version. And for here, you have more option for different IP protection. So now we have two options. One is IP40, and also the other is IP65. If you need waterproof or the proof from dust, then you can choose the IP65 version. And next is the axis number. And for now, we only have a 6-axis version of the articulated robot. But for more flexible, maybe in the future, we'll have a 7-axis version. And for generation, we have generation 2 for now. This is also fixed. And for the wiring, this means the tool in the end, how to wiring the tool in the end effector. For now, we don't have a standard version, but in the future, we also will have a different version choice. And with this number, it choose also the same, the cable between controller and the robot. So you also have a 3 meter and a 5 meter choice. And in the end, this alphabet is for the teach pendant cable length. So the same, you have 3 meter, 5 and 10 meter options. Okay, so here is our robot series model name. And the next will be the system overview. So you can see this is our basic architecture. So we have a robot arm here, can be a Scala or articulated robot. And then we have a controller here, and between them, we will use a cable to connect them to transfer like a power and encoder by this cable. And then with our cabinet, on the panel, we have many different connector. We can support many different device or communication. So in this picture, you can see like we have RS-232 and also 485. We can connect to our field devices like machine vision or some sensors. And we also have Ethernet to communicate to our device like HMI or teach pendant. And both of them are based on Modbus. So for 232, we have Modbus RTU. And for Ethernet, we have Modbus TCP. But for now, we're also working on the other Ethernet protocols like OPC UA and Ethernet IP. And we are also support these two protocols soon. And also we have a safety connector. So with this safety connector, you can connect to like fans or maybe some door sensor for safety. If a fence has been triggered or the door has been triggered, then it will stop or pause the robot immediately. And we can also connect to the external encoder, because for some application like conveyor tracking, the robot system need to know the speed of the conveyor. Then we need to use the encoder to feedback the speed data to the controller. So we also have possibility to connect to the external encoder. And next is the DMC-NAT protocol. So for DMC-NAT protocol, it's our Delta property protocol. Only Delta products support this protocol. So for the robot controller, usually we can connect two different products. One's servo drives and motors. So we can use a robot controller to control external axis up to 6 axes. That means you can control 6 different drives. And also we can connect to a remote I/O. If the digital input output in the controller is not enough for you, you can use the DMC-NAT to extend your digital input output by the remote I/O module. So this is our system overview of the robot. Is there any question for now? No, okay, then let's go to the next part. It's the robot arm. So in this part, I will introduce the robot arm itself. So first, this is the coordinate system in our robots. So first, we have this normal coordinate system with X, Y, and Z direction. So the front of the robot will be the X positive direction, and the left side will be the Y direction, and the upside will be a Z direction. And the rotate system we use is counterclockwise. So also means right hand rotation. And then for the axis itself, so you can see the joint 1 is on the base of the robot, and the joint 2 is connect between arm 1 and arm 2. And joint 3 is linear motion. It will move a joint end effect up and down. And for the joint 4 is for our axis rotation. So this is the DRS series joints. And here's the DRS series working range pictures. So when you are designing the machine or production line, it will be important to refer to these pictures, because this picture shows how the robot working range looks like. So for example, this DRS 40L series, the length of the robot is 400 millimeters. So you can see the radius here. This arrow indicate that the radius here is 400 millimeters. So you can see this big circle, the border are all 400 millimeters from the center of robot to the border. But you can see there are two small circles here. This means when the robot turns to this angle, you can see the angle is 130 degrees. It also indicates here. The first arm will be reach a limit. So only the second arm can still go to back of the robot. So in this small circle, we also indicate the radius is 200 millimeters. So that means in this small circle, the robot can move 200 in this area with a 200 millimeter radius. So right side is the same. So on the right, it's a DRS60L series. So you can see the working range picture is quite similar. So you can also reference to this picture to design your machine or application. And next is the DRV series joints. So the same, the coordinate system also defined like this. The front is X direction, left is Y, and the top is Z direction, and then with counterclockwise rotation system. And because we know this type of robot looks more like human arm, so we also name the parts as human arm. So you can see the this part to attach tool. It's also a wrist, just like a human wrist. And in the middle, connect between the first arm and second arm is our elbow. And on the base part is the shoulder part. And on the right side, we'll introduce the axis joints. So you can see the first joint is on the base of the robot, and you rotate the whole arms like this direction. And the joint 2 and 3 and 5 are parallel. So joint 2 is up of the base, and joint 3 is contact between the arm 1 and arm 2. And the joint 5 in the end to move the wrist in the same direction of our two axes. And the join 4 and join 6 is on the one line of the robot. It will be here's join 6, and in the middle of the arm 2 it's the join 4, and then they move in the same direction. So here is the working range of the DRV series. So you can see because DRV series is more flexible than the Scala series. It's not only on a plant, it's a 3D architecture. So you can see in the working range, we need 2 pictures to show the working range. So let's look at the right side first. This is the working range on the XY plane. It's very wide, almost a full circle. Only in the end, they are like around 20 degrees. It cannot reach in the back. And on the left, you can see is the side view of the robot. So you can see the range is also very wide. Here means the like this is a 700 millimeter because it's DRV 70L series. So that means from the center here until here will be 700 millimeters. And others, it's the working range it can reach, not always 700 millimeter, but still very wide. So for the 90L series, it's the same. It's a very wide area, just the length is longer. It's 900 millimeter. It's also indicated radius here. And then next is the connectors on the robot. Because for the user convenience, we also design different connector on the robot arm itself. When you are going to design the tool of the robot, sometimes you need a signal or air to control it. Like maybe it's a gripper or it's a vacuum pad. Then you must need to connect the horse or the digital input signal. So on the base of robots, we have one D-sub connector with the digital input-output signal, and also the air hoses here, and it will go through the robot arm itself and to the second arm, and you can connect here to the robot tools. Then you don't need to wire in this air hose or digital input-output signals on the robot arm. It can go through inside the robot. So for the 6L series, the basic is the same design. And for the DRV series, it's the same. We have the digital input-output in the base, and then you can control the tool by connect the tool's input-output signal to second arm. And then in the base, you can wiring out all these signals. And for the air hoses, it's the same. For the DRV series, we have 2 air hoses in the base. And on the arm 2, there will be a few air hoses you can connect to the robot tools. Okay, and with all this introduction, we are going to the quick start part. Once you have the robot, how can you quicker start the robot and to use it? So of course, first you need to do the power wiring. So for the robot controller, we support a single phase and from 200 to 230 volt AC with a PE ground. And we support both the 50 or 60 hertz AC power. And then the maximum current will be 15 amp. So if you are going to use a breaker or contactor, it's better to support until 50 amps. And then next will be about the control interface. So the first, you must connect these 3 connectors, then you can start to use the robot. So first, it's easy. It's the robot connector itself. So you just need to connect the controller with the robot arm with this cable. Then it's done. And next is the emergency stop. This is must connected. Sorry. So it's a 2-channel emergency stop. So both channel you need to connect it, then it will work. And if you want to connect more emergency stop buttons, then you can connect like this parallelly. And next, this one is also need to connect. This is functional safety channel. It has 2 channels. So this usually you can connect to maybe door or safety fence. And then if you want to connect more than one, it's the same. You can connect parallelly like this. And next one, this is only for the DRV series. For the DRV series, we have a safety reset button. So this reset button also have 2 channels, and you can connect the button like this. And this is for when the errors happen or the safety has been triggered, and you resume it, then you need to reset by this button to reset the state of a robot safety. So this is what these buttons do. And the next is you need to connect it the system input output. So for the system input output, you can see we provide many functions you can use by the digital input output. And the first you need to connect its mode selection. This mode selection is going to stack it's in auto mode or it's in teaching mode. So it's important, and we'll introduce details later. And for others, like you can control project state, like a run project or stop project. And also you can reset the alarm of the robot from the digital inputs. And for the outputs, you can get the state of the robot, like abnormal alarm state, several states. Also in place means if the robot reached the position. And also functional pause states, if the robot safety has been triggered, then this will be on. And also what project states, now it's running or stop. And in the end, it's the control ready. When you turn on the robot, and you will do initialization. When the initialization is done, then the control ready will be on. Then you will know you can start to operate the robot. So here is the mode choose input. So for mode choose input, you must choose one when you are using the robot. So first is T1 mode. If choosing T1 mode, it's input 1 to the digital input 4. And in T1 mode means this is a manual teaching mode. So for safety, it will limit the speed under 250 millimeter per second. So it will be slower. And for the auto mode, this means when you are finishing the programming and you need to start to run the project, and you can choose this mode. So this mode, you just need to input digital input 5 to 1. Then of course it's running in the full speed, and you can run the project under this mode. And here's the for your reference, you can use the digital input 6 and 7 to control the project. And only the spatial is for run signal. You need to keep this signal on for 3 seconds, because for safety reason, then the project will be running. And also, if you need to connect use the digital input output, that means this digital input output is for user definition. user can define what the function of this input output for. So for the input, we have 24 pins, and then we support both MP and PNP wiring. And for output, the same one, we have 12 pins, and we also support both PNP and NPN wiring. Okay, and the rest will be the appendix, like some hardware limit and installation. So just quick go through this part. So for the because for C certification, we have a hardware limit on all the robots. And if you need to adjust these limits, you can refer to this part in the menu to adjust those hardware limits. Also DRV series. And for robot installation, we use 4 MA screws, and we suggest a 20 Newton meter to fix it. And for DRV series is similar, just the torque we request higher is 25 Newton meter. Also, we suggest for the controller, you need to install with some space to let it have space to do heat sink. Then it won't be overheat. Okay, so this for all the introduce of the robot system. Is there any question for now? Okay, and if not, I'm going to the software part. I will introduce the software DRAStudio, how to use it to control the robot. Okay, so the next presentation will be about DRAStudio. So DRAStudio is the main software we are going to use for controlling the robot. And here's the contents. So first I will introduce about the user interface, how it look like. And then the basic commissioning, how we jog robots and teach some points. And then I will introduce how to measure the product, and then also how to measure point, or point table in the project. And in the end will be some general functions you will be using in the commissioning. So first is the user interface. So once you open DRAStudio, you will see this interface. So basically the left side is our main screen to control robot. And right side is actually screen that you can use some functions as a help to control robots. And of course, you can see the version and also release date here. And so first, what you need to do is log into the software itself. For now, we have 3 different permissions. This is for different operators. Like first is 111. We defined as an operator for the production line. They can use this permission to like run the project, start project. Those are basic stuffs. And 2222 is for the engineers who are going to program the robot and set some settings of the robot. And the last one is the maintenance permission. With this one, you can change the parameters of the robots. Also, you can upgrade the firmware, also some maintenance stuff. So you can use these 3 different permissions to log into the software. And usually we will use 2222 to log in here. So after login, you can go to click this button to choose the robot type. So you need to choose the right robot type to operate the robot here. So you can see robot type here, like this example, you choose a VA and then choose a robot model and the control and application. And of course, in this software, we show the system state of robots. So first is the current user on this top menu. And second is robot type you choose before. If you choose a VA, this will show VA. And if you choose a Scala, you will show a Scala robot here. And next is connection. If you connect to a robot, then this will be green because now it's a disconnect. So this will be orange. I'll show this function later. And then the servo state. And if all the servos on robots are on, this will be on. And if any joints is off, servo is off, then this will be off. And then here's a TP states. So if your robot connect to a teach pendant, then and the teach pendant operation is also on, then this will be green. That means now the operate permissions on teach pendant. And next is the state. Now it's a T1. That means you choose the T1 mode in the system digital input. And if you choose auto, this will show auto. And next is alarm. When the alarm happens, this icon will show red. That means you have alarm. You cannot operate. Otherwise, you'll be grayed out. And here's a button to reset the alarm. And also, when you open the project, you will show the project name under the state bar. So this is just the same as the system digital input I showed before. It will going to choose a different mode. And then when you are connected to the teach pendant, it will show different states if it's connected or not. So let's start the basic commissioning part. So in the beginning, of course, you need to connect to the robot itself. So basically, we are using Ethernet to connect to the robot. We strongly suggest use Ethernet. But actually, you also can use the USB to connect to the robot. But with USB connection, there are many functions will be missing. So we only suggest use the USB connection to get the IP address, because sometimes maybe you forget or lose the IP address setting, then you can use USB connection to get the IP address and then go back to Ethernet connection. So usually the default IP address of robot control is 192.168 and 1.1. So after that, we can connect. So after connecting to the robot, the first thing we are going to do is the servo on the robot, because if the servo is off, then we cannot control robot, it cannot move. So there are 2 ways. One is just click this servo on button. Once you click it, then all the axes on the robot will be servo on. And you can also go to the servo page on left here, and you will see all the servo states on the main screen. And if you click the slide on the top here, you will also servo on all the axes. And also, sometimes you need to release the brake of the robots. Then you can also operate the brake here to on and off the brake. And after you servo on the robot, then you can start to jog it to check if the robot moving correctly. So on the right panel, you can see there's a jack page. Then when you go to the jack page, you will see this panel. Then there are many different options, like you can choose the jack mode, also speed and distance. And for testing, I would suggest choose the medium and continuous distance. Then it's easier for jacking. And you can also choose a user friend, true friend. I will introduce later. So after this setting done, you can use these buttons. When you click and don't release it, then the robot will move. Okay. And next is project management. So basically, our software is also project-based. So for each maybe machine or application, you can create a project. And in the project, we store like point information or also programming information and some settings of robot. So in the project page, you can right-click on the DROE solution. Then you can add a new IO project and name it. And of course, you can also choose the project to edit and also delete the project and rename the project. And also in the end, when you are done for programming or commissioning, you can upload to a controller, then the robot will run the project by itself. So in this project page on right side is controller storage part. Then on the controller, you right click and click update. It will show all the projects inside the controller storage location. And with the two buttons in the middle, you can transfer the project between the controller and the PC. And this is really easy. You just need to click the project, then click this button, it will transfer to controller. And on the controller side, if you choose the project and click this button, then it will transfer to PC side. And next is the point measurement. So in our robot system, we have two different point table. One is the global point. This is a point table which just stored in the robot controller. So this one only can store up to 1,000 points, but this 1,000 points can share by all projects. And the yellow one, local point, it can store up to 30,000 points. It's much a lot, but these points are only stored in the project. So means only the project itself can read these points. And for each point, what data we store inside. We store different data between different robot type. So on the left side, first is a Scala. For Scala, we store the ID and name of this point. And we also store the coordinates. But for the coordinators, we only store X, Y, Z, and RZ because Scala only have 4 degree of freedoms, and there are X, Y, and RZ, X, Y, Z, and RZ. And also post, because beside the coordinates position, the post of the robot itself is also need to be storage. That means the arm can be on the right hand side or left hand side. We need to record it. So we also have hand information. And then we also have storage the frame information like user ID or tool ID. And this I will introduce later. And we also store a joint index. What's joint index? Basically, is how many turns of the joint has already turned. And why only joint 4? Because actually only join 4 in the Scala can be rotated unlimited, because from join 1 to 3, they are always limited when they turn to angle. So it cannot even finish a one turn. But only join 4 can turn more than one turn. So we need to record how many turns of joint 4. That's why we need to record joint index of joint 4. And on the right side, practice the same, but for the VA robots, it has 6 degree of freedom. So we need to record all 6 coordinates like X, Y, Z, R, psi, Y, Z. Also for the pose, because for VA we have elbow, shoulder, and flip. Flip picture means the wrist part. We also need to record this status. And we also have a friend, the same. I will introduce later. And for the joint index, it's also the same, just for the VA robots. For the joint 6, it also can rotate unlimited turns. So in the VA robot, we record joint 6 and 4 joint index. And next is the teach and go function. So for this joint table, of course, we won't ask user to imagine those points and input by themselves. We have a function to teach these points by moving the robots. So first, you can use the jog function in the before I introduced. Then you can jog a robot to the position you want. And then use the teach function to teach a current robot position to a point. So when you click teach, all the information in current position will record into point. Then all the information is on this point. But when you are going to test this point, then you can click this point and click go. Go function means they will move the robot go back to this position. So it will move to the position. Okay. So before going to the general functions, I want to use the software to demo the robot, how to use those functions. Okay, I think for now you can see the software on my share screen, and from my personal screen you can see the robot itself. If it's too small for you, you can zoom out the video by yourself. So as I mentioned, as I mentioned, when you open the software, you can only see like this without any functions. And the first step, we need to log in the software. And here we use 2222. Okay, login. Then you can see all the functions, the page you can use when you log in. And the next, we need to choose the robot type here. So now for the demo robot, we are using a Scala. And then it's DRS6L6 SSA series. So we choose this model. And then we click OK. Now we have a red model. And next step, we need to connect to the robot. And for this robot, because I changed the IP, so it's 41 in the end. And let's click connect. Okay, so now you can see this button is become green. That means we already connected. So first we go to server page. Now we can serve on a robot by this serve on button. So you can see all the exits are on now. So that means we serve on successful. And then also the mode you can see here is auto. That means in this robot, I connect the system digital input output to auto mode. Okay, so now it's already served on. Then let's go to the job page on the right. So in here, we only need to choose the speed to medium and the distance to continuous. Okay, so then now we can start to juggle the robot. So if you can see, when I click this button X, you can see a robot is moving. If you click the button and don't release, and also the XYZ information is changing when I doing the robots, moving robot. So this is a basic jug function. And then let's go to the project here. So as I mentioned, we need to create project here to store different projects or point or application point, and also programming. So let's right click here and add IO project. And let's say it's project 1 and click yes. So now we have a project 1. It's already open. If you are not sure, you can choose project 1 here and click edit project. Then it will also open the project. Okay, now if you see the project name here, it's a project 1, the one we opened, then it's successfully. Then next, let's go to the point. So in the point, it's a new project, so you can see it's all empty. So now we can start to teach few a point here. So now, for example, I juggle the robot to a position I want. Then now I choose a empty point here. And I can click teach button. So here is a dialog to inform you, then click yes. So you can see all the information is in the point now. So now I want to teach 2 more points. So I click add points here. So I have 2 new points, and let's move the robot again. And then teach. And the next one. And then teach again. So now we have 3 points already told. And it's all in orange because it haven't saved into project yet. So we can click the save button here. Then it will save the point into the project. So now it's all white again. So now I want to test these points. Then I will click the points here. It will become highlight. Then I click go button. You can see robots moving to this point. The next one. And the next one. So now you can see how to teach points and also test these points is correct or not. Okay. And then let's go back to the presentation. Okay, so next part I will introduce some general functions of this software. So first is the very important is the robot editor, language editor. This is for programming the robot and also debug it. And I will introduce this later after I introduce the language. And next is the function page on the right side. This is using for read Modbus, Modbus address in the robot controller, because for our controller is default as a Modbus server, a slave. So it has its own Modbus addresses, and you can use this function to read values in these addresses. And here's the home page. In this page, you can set all the, so not set, is let all the joints go to home, and you can check if the robot home is still correct, because if robot home position is not correct, then all the points or maybe accuracy will be wrong. And here's the IO page. In this IO page, you can check your user input output, and also the system input output that it's on or off. And for this white area, you can also write your own command then to remind you this input or output function. And for output, you even can click on these buttons, then it will enable the output to test. And next is the tool frame function. So this function is when you attach a tool on the robot, usually you need to let robot know the tool tips, where is the tool tip related to the robot itself. Then you can teach this tools points correctly. And next is the user friend. Because for some application, you need your own definition coordinate, not only the robot coordinate. So you can use this function to define few different coordinates by yourself. So for these two functions, I will introduce the details later. And the next is the information page. So in the information page, you can check all the information about robot, like the position of each joint, and the velocity here, and also the torque, and also the coordinate information, just like a jog page, and also the alarm information. If an alarm happens, then you can check where is the alarm from. It's from controller or the motor group or each motor itself. And for control information page, the important here is you can check your firmware version. Usually we will ask to this version when we are help you to solve issues. Then we will know in which version has this issue happened. And for the alarm history, it's also useful for troubleshooting. So you can see all the alarm happens before, what happened to this robot, and to check maybe it has a damage before or something is not okay. And the last is the system settings. And in here, basically is for communication settings like IP address. You can change the IP address here of the robot controller. And also you can change your RS-23245 parameters, like which mobile protocol you're going to use. Also the baud rate of the protocol. And the last is you can change the software language. But for now, we only support English and Chinese. And I think most of you will choose the English version. Okay, so for the software introduced, this is all part. Is there any questions here? Okay, if no, we are going to robot language part. Okay, then let's start the next part. Next part, I will introduce about robot language, how to use the robot language to program the robot. Okay, because I just answer one question and we can continue. So for the robot language part, we will have this contents. So first I will introduce the basic syntax of the robot language. And next will be the motion instructions. And then for the point measurement, we also have instruction in the robot language. And then there will be the communication part of the robot language. And in the end will be some advanced functions that will be convenient to use. So first part is the basic syntax. So for the basic syntax, is first is the statement separator. If you have language basic, all the language need to have a statement separator. So in our robot language, you can use commas or just a blank space or a new line. So for example, on the right, it's a separate statement by a blank space, and also can do like the second line here, it's separated by commas. And we also have a single command. And for single command, you can see you just need to use a 2- in the beginning. Then this line will become a command. And if you need a block command, that also means a multiple lines command. You can use a double dash and then double bracket. Then you can write all your commands in this area. And then in the end, you can use a double dash and then double right bracket again. So in this area will all be commands, not a program. And then next will be the operators. So for operators, we support all the basic like add, subtract, multiply, divide. Also its potential. And we also have a logic operators like and or not. It's easy, just like English word. And also for comparing, we also have a greater or equal, less or equal, and not equal operators. And here's about the variable. So for variable in our language, it's easy. Actually, you don't need to define before to use it. You can just use it. So in the first example, it's global variable. So you can just assign a value to the variable you want, like a equal 1, b equal 2.1, and c equal test is a string. So string, just like other strings, you can quote by a double quote. And then there's a local variable. So what's the difference between global and the local variable? So for local variable, then you need to kindly define it by a local keyword in the beginning. Then this variable will become local variable. And then let's see the example on the right side. In the beginning, it's a equal 1, so it will be a global variable. Then it will be accessible from all the program. And then let's go to here. This is a if section. So in the if, we define a local variable b here equal 2, and then a global variable c equals 3. So after the if section, then a and c still can be accessed, but b variable cannot, because it's local. That means only available in this section. So after this section end, then you cannot read variable b anymore. So that's the difference between global and local variable. Next is the table. So in the table, we can store a list of data. So how to define it? So first, you can see this example. So for the list 1 equal to buckets, that means this is an empty table. And secondly, this 2, we use the left bucket and then the number and separate by commas and right bucket. That means we define a table with some predefined numbers inside. And then how to use it? We can use like this is similar to actually other language like C. You can put the list name first and then use the right bucket with the index inside. This is index 1. And by the way, this table, the index is start from 1, not 0. So it start from 1. So we want this index 1 equal 3. So that means in the list 1, this list, the index 1, the value will be number 3. And if you are going to read, then the same, you use table name and then use left right bucket and with the index inside. So this index is 3. So in the list 2, index 3 is number 3. Then the data will become a number 3 to from the list. So this is a table. And the next is the if statement. So if conditional statements to judge a condition, that if this condition true, then you will go to run these statements. Then if a condition is false, then you won't run these statements. So this is an example, like the first one, if this condition true, then it will move to point 1. And if this is not true, you will go to else if. Then if this condition is true, then you will go to move to point 2. But if this also false, then you will go to else. Else means all the condition of it, other if it's false, then it will go to else and move to point 3. So this is if statement. And then next is loops. So in the robot language, we have 3 different loops: while do, and for do, and then repeat until. So you can see the 3 different example here, but do the same thing. So first is while do. So in the while, we put true. In the robot language, also have a true keyword. It means always true here. So it will repeat this loop until if I equal 100, then it will break. Break means it will jump out of this loop. So in the end, I will be 100 because it run 100 times. And the second is for do. For do is for easily for go through the list, because for the for you can define the index I, begin with the initial value and the end value. So that means this loop I will go through from 1 and add 1 in each loop. So it will go from 1, 2, 3, and in the end 5, and it will run totally 5 times. So in this loop, you can use this I as an index of the table. Then you can access to each elements in this 5 times loop. So the last one is repeat until. The difference of repeat until it's it will always run the section statements once first before judge the condition. So for this repeat, it will add the sum and also add the index once and then judge the condition. And the condition here, you can see a special symbol shop here. So shop means it will count the elements number in the table. So shop A will means the size of table, and the A, you can see this table have 5 elements. So shop A will means 5. So in this loop, it will repeat until I is bigger than 5, then this loop will be end. So here is our 3 different loops in the robot language. And the next is function definition. So in the robot language, you can also define your own functions. If you are going to call some functions multiple times, then define them as a function will be convenient to use. So to define a function, you need to start with a keyword function, and then the function name, and then the input. You can define how many inputs you need. And also, it's same as a variable. You don't need to define the type of it. So in the function, you can use these imports, do everything like a plus or the application you want to do. And then use a return keyword to return output. So here we return the X, Y, and Z. And then in the end, you need to put the end to end the function. So how to use the function is also similar to other programming language. So you can use the function name to call it, and then input values you are going to input to this function. And here, like we input 1 and 2 and 3. So this will go into ABC you define here. So of course, it will add these 3 numbers with these 3 numbers and then return. So because we return 3 variables, so in the left side of equal, you can also use the 3 variable to catch them. So the X will go to M, Y will go to N, and then Z will go to O. So this is how to define and use the function. So until now, it's the basic syntax and statements. Then now I'm going to motion part. That is motion instruction of the robot. So first it's move P. This is the best part if you want to use the robot movement. So you just need to define the point you are going to move. So move P means point-to-point motion. That means only reach the target position is matter. So in the beginning, I mean in the between, it doesn't maintain the path. So with this instruction, you will use all the motors as a faster speed to reach your target. Only the target will be accurate. And the move L is a linear motion. So because it's a linear motion, you will try to maintain between target and current position as a line because it's a linear motion. So that's a difference between move P and move L. So here is an example of a usage of the move P and move L. So for the move P, in the beginning, you can do very simple, just put a point number like 1 here. Then the robot will move to point 1. And then you can also use the pass function I'll introduce later. Or you can also choose a different speed and acceleration and deceleration. And you can also use the name of the point, not the number. And you can see it's the same. You can choose speed, also pass function. And then there's another convenient function. Is you can use this add and then z with the number. This means we're going to this point P1, but I want to shift z direction 10 millimeters and also shift RZ 20 degrees. So this is a convenient function to adjust the target to different position. And there's also another programming way that you can use these small functions like APD to change the speed and add the acceleration and also add the pass function. So basically it's the same, just a different programming way. So on the right side, you can see a move L basically are the same usage, just it's a linear motion. And this one is to introduce a pass function. So pass function is also a useful function to use. For example, you can see here. Now our target is here, 0.3, but because maybe here there is a obstacle or somewhere we need to avoid, we cannot go through here. Then we must to have a middle point to avoid the obstacle here and then reach the 0.3. But if you use a normal injection, like move L to 0.2 and then move L to 0.3, it will be slower because in 0.2, you will also try to reach the target accurately. Then you will spend a little time, maybe a few milliseconds. Then it's slower. But this point is not important because we just want to avoid obstacle here. So we don't want to spend time in this point. So now we can use pass function. Then that means we can write the program like this. We want to pass 0.2. So on the robot, you can see this result. When the robot is going to move to 0.2, it won't really reach 0.2. It will start to turn to 0.3 before reach 0.2. And so it will be a smooth curve here and then go to a 0.3, our target. So with the same function, you can save a little bit time in the 0.2. And so in your whole application, if you use it to save time, then you can save a lot of time in the total operation time. And the next part is the relative distance motion. So it's similar. You have two versions. It's one move PR. It's one is move LR. So move PR is move relative distance by P2P motion, and the move LR is the move relative distance in linear motion. So how to use it? Then in the move PR, you can assign one direction. Like here, we assign the X direction, and we want to move 10 millimeter positive. Of course, we can also use a negative value. Then you will move the other direction, the negative direction. So you can use in all other different direction, even like RXRZ. And you can also define in which coordinate, like here we want to move in the two coordinate Rx, and then the 10 degrees. Also, you can change the speed here. And for the move LR, it's the same similar usage, just different motion. It's a linear motion. And the next is MRP. This is the spatial motion for pick and place. So this is the pick and place motion. You can pick stuff on the right side and move up, and then move horizontal, and then go down to the place target. So here's the usage. First is the target, and then the 0 means the Z top, and then 50 and 40 means the H1 and H2. So we can define all this distance to finish a pick and place motion. And then next is a motion arc. That means doing arc motion in this instruction. So we use border mass to define our arc. So border mass means we define 3 points on this border. Then the robot will calculate and move arc motion by these 3 points on the border. So because current position is also one of the 3 points, so you just need to define point 1 and point 3, the middle border position and the target position. And in the end, you can choose the border mode. Now is the only mode we can use now. So for others, you can also change speed, also use the path function. It's similar to other instructions. And the next one is the M circle. It can move the robot in the circle motion. So for definition, it's similar to the arc motion. Just for the circle instruction, you will finish the whole circle and then go back to original position. So this is the M circle. So you can see the usage also similar to M arc motion. Okay, and then here is the point management. So I'll go fast here. It's first you can use this to manage the global point. And then you can use the read-write point to change the informational point, but it's only temporary. For the global part, it's permanent, but for the read-write point function, just temporary. And you can also copy the points between each other. And then the communication part, we can also use a DI and DO function to read or change the speed, change the state of the digital output. So you just need to take the number of the input or output, then you can set it on off or read the state. The next is a mobile slave function. So as I mentioned before, the robot controller itself is a mobile slave. So it has addresses, mobile addresses, then you can use the write mobile function and also read mobile function to rewrite this information. And for the robot controller, we only let user to use station ID 2 and from address 0x1000 to 0x1FF. In this section, the user can define the usage of those addresses. And use the robot language, you can also use the mobile TCP client function. So with these functions, you can connect to other devices by IP address, and then rewrite by write MVC and read MVC function to other mobile TCP servers. And then here is the advanced functions. First one is the multitask. So for the multitask, you can run many different tasks in the same time. So if you define the task you want to run in the 3 different functions, and then run the multitask function and put the function name inside like this as an input, then once you run this multitask, then all the tasks will run in the same time. And the last is to quit or pause the program. So you can use the quit function to quit the program, and the all project will just stop. Or you can use just a pause function to pause the project, then the project will be paused, and you can use the run button or from the mobiles to run the project again from the pause position. Okay. So for the language part, is there any question until now? Okay, if no, I will go to show you how to debug the robot language for now. Okay, so now I'm going back to the DRAStudio. So in the before we already told there are 3 points in the project, right? So now we are going to use these 3 points. And then let's go to our page. So in our page, basically you can see all the function you need, like start. This means start debug. And then here's this breakpoint, because we can set breakpoint in the language. I'll show you later. And all those other text functions like cut, undo, comment. So let's start to write the program. So first, you can also do the servo on in the program. So let's see on the right, there are many buttons. So this buttons is convenient to insert examples. Like now we want to do robot servo on. So you can just click this button, then it will insert bigger, insert robot servo on commands here. Okay, and then now I want to set a speed in the beginning. So you can see here also many buttons you can just click. So now I insert speed joint, acceleration joint, deceleration joint, also speed linear, acceleration linear, and the deceleration linear. So we define 2 different group of speed. For the speed joint, that means for point-to-point motions, and the unit is percentage. So now it's 10% speed and 25% acceleration and the deceleration. And for linear motion speed we define in another group here. And the unit is millimeter per second. So now for the testing 1000, it's a little fast. I change to 100. So now we finish set up a speed. Now we can start to do the motion. So for the move L and move P, of course, we also have buttons here to insert. You can insert one move P, move L, and move P again. So now we have 3 motion commands. And then let's change the points here to the points we taught before. So first is 1001. We can check. The first point number is 1001. And second one, I want to use the point name. So just remember, you are going to use the point name. You need to use this as a string. So you need to use a double quote to call it. And let's use the number again, 1003. So it's already finished our basic functions. So we can try to click a star here to test it. So it will inform you start the programming. So you can also see the green highlight. That means the robot is surrounding this line. So if you also can see another screen, the robot is moving. Yeah, so then it's finished now. So this is the basic program of the robot. And then if you want to debug, you can set some breakpoint. This is the easier way to debug. So for example, if I set a breakpoint here, this line, I just need to click in front of it. And there is a red dot here. And also the line will be highlighted in red. And let's try to start again. Okay, so you can see now the program stop in this line. So now we have a few options. One, so we can click continue again, then the robot will finish rest of the program. Or we can step this line. That means we will only run next line until next. Okay.
Jason, can you hear me?
Okay, then we are going to start the last part of today. We'll introduce about friends, including user friends and tool friends. And also in the end will be the singularity of a robot. It's some forbidden points. Not really forbidden, but we suggest not going to reach those points. So here's the contents. It's robot coordinates and then tool friend first and then user friend, and the end is singularity. So first is robot coordinates. So in this picture, you can see the definition of the robot coins, robot coordinates in a robot. So first it's a robot friend and the world friend. So you can see the robot friend and world friend here are separate, but in our robot system, because we only have one robot, so our robot friend and world friend are the same one in here on the top of the robot. So this is a robot friend. And we also have an effect friend here that define the an effect of the robot. And but in the factory, we already do a collaboration between these two friends. So robot itself knows the relation between these two coordinates. But if we install a new tool on the end effector here, and usually we're using the tooltip to work on the workpiece, but robot doesn't know where is the tooltip. So we need to do a tool calibration to let robot know the tool friend. So we will create a tool friend for tool. And sometimes some project we want to define our own coordinate. We don't use the robot friend. Then we will create a user friend here. Then we need to do this workpiece calibration to create this user friend. And the next is the coordinated rotation system. We use this system that we rotate Rx first and then rotate Ry, and this is Rz. So the order is pitch, roll, and yell. And then first is the tool friend. So for the tool friend, we have two parts we need to teach. One is TCP, one is tool rotation. So what's a TCP? TCP means tool center point. This means it's the point we will work on the workpiece. And this originally will be in the French on the robot. Then after the calibration, we will move this point to the TCP here. The other is the tool rotation. If sometimes this tool has an angle, it's not the same as the robot original French, then we also need to teach this rotation of the tool. So to teach TCP, we have these parameters, the width and the angle and the height of tool. So where are these parameters? You can see in these pictures, example pictures. So basically the height is the height from the tool tip to the end effector. And the width will be the width from the end effector to TCP here. And the angle is from the X direction to the width. So it's a theta here. So for the 6x basically is the same. So we use these three parameters to define the tool tip. So in the DRAStudio, here's how to set up the tool friend. First, we need to go to points page, then tool friend page. And then we can choose an ID. So we can teach up to 9 different tool friends in the robot system. So on the upper part, set TCP, and the lower part set tool rotation. So we will introduce about upper part. And upper part, if you have the 3D drawing of the tool, you can calculate these 3 parameters and input these 3 parameters by yourself. But if you don't have, then we have the calibration tool can help you to do a calculate of these 3 parameters. So how to use the calibration to teach TCP? So basically, when you go into the tool, you will see this table. Then this table, you need to teach 3 to 8 different points. By this way on the right, you can see these arrows, you can see it's a tool. And we will use another fixed point on the ground or table. Then we try to reach this same point from 3 different angles. And these 3 different angles we can teach on this table by this teach button. And after we teach more than 3, of course, more points and will be more accurate. Then we click calculate arrow and then click output set. Once you click arrow, calculate arrow, you will see all the parameters already calculated by the software. Then click output set, you will set into the robot controller. So here is the real pictures you can see. This stick is a demo tool, and you always reach the same point by this TCP, but from a different angle. And next is the tool rotation. So for rotation, we have 3 different parameters. It's origin point and x-axis point and y-axis point. So how to teach is similar for origin point. You also need to touch the TCP to a fixed point on the ground. But the second difference, you need to teach the x-axis of your tool and move along the axis and then teach your x point. But actually, for most of tools, this way it's not easy to use. So for the tool rotation, we will suggest to use 3D drawing and to calculate pitch and roll yard directly and input into the system. So here's the tool frame. And next is the user frame. So as I mentioned before, tool user frame is to define the customized coordinates. And you can teach more than one here. So then you can teach a point on these customized coordinates. So how to set up the user frame? You also go to a point page and then user frame page. And first, you also need to choose the ID. We also can teach up to 9 user frames in the system. And then we need to input these 3 points to define a coordinate. So here you can see how to teach it. So in the beginning, you can teach the original point. That means the original of the coordinate. And in the second point, you need to teach the x direction. And then the next point is the y direction. So with these 3 points, you will define this coordinates. And then you can click set here. Then you will set into a robot system. So this is the user frame. So the last part of today is Singularity. There's some points that better not let robot pass by layer because it's not good for motor and mechanical parts. And for this part, we use a VA as an example. So first is the wrist singularity. So that means when the joint 4 and joint 6 are in the same line, then the joint 4 will instantly rotate 180 degrees in the fast speed. So when you are designing the motion of a robot, better don't let the joint 6 and 4 be same straight line. So how to avoid? Then of course avoid to joint 4 and joint 6 into a straight line. Or maybe you joint 5 can jog more than 5 degrees, then also 4 and 6 won't be in straight line. Or maybe you need to modify the tool to avoid it. And next is shoulder singularity. When your wrist and joint 1 is in a straight line, then joint 1 and joint 4 will instantly rotate 100 degrees in the same time. Then this is also not a good position for a robot. Then yeah, try to avoid it by join to another point, avoid this part, or also you need to modify the tool to avoid it. And next is elbow singularity. So this one is you need to avoid joint 2, joint 3, and joint 5 into a straight line. Otherwise, the elbow part will be stuck. So of course, how to avoid? Don't let the joint 2 and 3 and 5 onto a straight line. And maybe also modify tool, because usually in this situation, because the tool is not long enough, maybe if you made the tool longer, then you can solve this situation. Okay. And here's an example video that maybe you can check by yourself. This is easy, you can do search online or YouTube. Okay, so this is the end of this part. And so I think it's almost time, and it's the end of the online training today.